I am recording now. Yeah.
Real quick. Hold on.
I got really bad allergies, so my body fights me a lot.
What happened?
I said I really got bad allergies right now, so my body fight like sneeze a lot.
It's alright.
Oh
Just
shit,
wait
my
on.
webcam just dropped.
We have to wait on Eric. Huh?
Yeah, I think so.
Probably getting food or something.
Fuck, where is my work at?
Yeah, we're recording now.
My name is Eric Cow.
I'm Maximus Beasley.
I'm Alonso Hernandez.
I'm Wilmer Manzano.
Theater Lara, and this is a good meeting. Number one then.
Yeah, start on number one.
So what I put for number one is a lot. I said that the depth cues used for one eye are occlusion, relative size, perspective convergence, and familiar size. Occlusion occurs when one image partially blocks the view of a second object and the partially hidden object appears farther away as a result. In the example, the flower bed blocks part of the girl's leg. Another example was when the bushes block part of the tree trunk. Third example would be a child standing in front of a car. Because the car is partially hidden behind the child, we assume the car is further away. Relative size is when two objects are of equal size. The one that is further away will take up a smaller portion in the retina. An example of this is flower bed C is smaller than the rest, making it look smaller and further away. Another example is the man sitting on bench. A third example are the trees behind the bushes. The further away they are, the smaller they become. Perspective convergence is how parallel lines move away from us into the distance. They seem to converge or come closer together. In the example, this can be seen on the tiles when they slowly get closer together the further away they become. Another example is paint on the road. Assuming they're perfectly drawn, the further away they are, the closer they will become. A third example would be the lines drawn on the floor in art. How do I write? Okay. To convey distance, the lines may be getting closer together. Familiar size is when we judge distances based on our knowledge of that object's size. An example in the picture might be when the cat recognizes that the boy and the girl are almost equal in size, and as such, if the girl is smaller than the boy, then that means she has to be further away. Another example may be the flower beds. Assuming they're the same size, smaller ones should be further away. Third example would be the trees. They're all the same size, smaller one will be further away. I hate this question.
Yeah, there's like 2 paragraphs for me for the answer. I mean, I put pretty much the same things. I just said that one Q is occlusion, and then it's relative height, and then relative size. And some examples are the same as yours. Like there's an example of occlusion can be like you see the guy in the bench in the back, like he's covering part of the bench, like so you could say that that he's closer to us on the bench. And then for the trees too, like some of the trunks are being covered by the bush, meaning that the bush is closer to us on the tree. And then like relative size is like with the flower beds is like A is bigger than all of them, meaning it's the closest ones to us. And also with the squares on the floor, like they were drawn on purpose like that too. Like the closer ones in the front row are bigger than the ones in the very back. Those are really small. Yeah, that's pretty much what I have.
Yeah, I didn't really, yeah, I didn't do that one. Well, I did, but like, it wasn't, based on what you guys are saying, like, mine's hella wrong. Like, I don't even wanna say it.
Like,
Mine's,
that one was a little like confusing for me, but I mean, I got that one down. So
yeah.
I mean, the second one's kind of easy too, because this one's just about one eye. So like the second one's comparing it with two eyes. Like what is that called?
yeah, for that one I wrote the one I tried using a monocular depth cue to perceive the image because it only has one eye due to past incident. The next three examples of depth cues are monocular depth cue, which require one eye and is also referred to as a pictorial cue. It discusses occlusion and occurs when one image particularly blocks the view of a second object. The partially hidden object is seen as further away as the whole object. The second depth cue is known as the relative height. To effectively use this cue, we must also use our knowledge of horizon. Objects are closer to the horizon will appear further away, and the greater distance between the object and horizon, the closer the object will appear. The third cue is the relative size. The one further away will take up a smaller portion of the retina. The one-eyed cat uses the horizontal lines and shadows to perceive depth, and is an example of the relative height, as also the monocular depth cue since it is looking at 2D images such as a picture using one eye.
Oh, number two is back when the cat had two eyes, what kind of depth cues could he use? Provide a brief definition and description of that cue. Make sure to include a conversation about what is happening in the brain with the eyes and images on the retina. Um, when this depth cue is used. What happened for that one is that it could be called binocular depth cues, which include retinal disparity and convergence. Eye convergence is the ability to turn both eyes inward to focus on a near object. Some examples can be working at your computer, trying to focus on your mouse. Retinal eye disparity is when the use of both eyes refers to difference the between the view that each eye receives of a given object they're seeing. It's useful because it could be used farther away as images become farther away. They have a smaller degree of disparity on retinas, and the brain calculates the depth information by comparing the images from both separate eyes.
Yeah, I pretty much got the same thing. I just put, it can now, detect the binocular cues and it's the involvement of two eyes while monocular only requires one and can be presented in two dimensions. And that the cat would finally be able to perceive more of a depth perception. And this is
Yeah.
because to successfully process an object relative to its location, the brain needs like two eyes, the cones and the resources to base the object of to get that depth perception. I don't know if that makes sense, but yeah, that's pretty much what I got.
I said that a binocular cue that the cat would use would be retinal disparity. Retinal disparity is when as images become further away, they have a smaller degree of disparity on the retinas due to the fact that your eyes are in slightly different locations on the head. So each retina has a slightly different image of the world. The brain also uses the degree to which the eyes must turn inward to focus on an object. When an object is in the distance, the eyes look mostly straight ahead. The brain can use the tension in the muscles in the eye to make determinations about depth.
For that one I put down, when the cat had two eyes, he used the binocular cue and required input from both eyes. The brain is making comparison between the two eyes in order to understand depth because its eyes are in slightly different locations on his head. Each retina has a slightly different image of the world. This retinal disparity is a useful cue because if images become further away, they have a similar degree of disparity of the retinas. The brain calculates depth information by comparing the images on the right and left side. The brain also uses the degree to which the eyes must turn inward to focus on an object. When an object is in the distance, the eyes look mostly straight ahead. The brain can cause attention in the muscles in the eye to make determinations about the depth.
Does anyone else want to say what they got for number two or what? Or is that it?
Just to also add, I said that retinal disparity is also said that both eyes process different images as the distance between objects and eyes increase or decrease given the information the brain processes about depth. And I think it said the greater the disparity, the closer the object. That's pretty much it. But like everything else is the same thing you guys said.
Yeah. You want to do number 3 then?
All right. Let me see. 3 says, while watching the recent presidential debates, you find yourself zoning out and instead looking straight at the American flags directly behind the candidates. You stare at the flags as you listen to the debate. Now explain how your brain sees the colors of the American flag using the trichromatic color theory. Make sure to name and describe the different cone cells in the retina that supposedly let you sense the colors of the flag. And also make sure to explain what's happening in the brain and how action potential is coming from those cone cells. Create the perception of color. Let me see what I put. I said that the trichromatic theory of color is based on the premise that there are 3 cone receptors for color. The principle is that it's possible to match all the colors in the spectrum by mixing the primary colors appropriately. And what I put, by having these, having the primary colors all together, this is your brain using the action potential to fully process these colors, which creates more attention toward the flag. And let me see. Yeah, that's pretty much what I got.
Okay, what I got was that there's 3 cones, right? The L, M, and S cones. The L responds to red and orange colors. The M cones responds to green, and the S cones responds to blue. When we're perceiving something like the American flag, we use all 3 cones to perceive the colors of blue, red, and white. We see the white stars and lines in the flag when all 3 cones are stimulated equally. The cones then send AP signals to the temporal lobe so that the brain can identify what colors we are seeing.
For now, when I put down that trichromatic theory of color vision, it proposes that color information is identified by comparing the activation of the different cones. Looking at the blue color in the American flag, the blue is reflecting short wavelength to the eye, which activates the S cones, but not the M or L cones. When looking at the red color in the flag, the red reflected from the light activate the long cones, not the M or S cones. The white coloring flag appears colorless and is actually an equal representation of all color wavelengths. The human eye has 3 types of cones. One type of cone responds maximally to short wavelengths and has been named as short cones or S cones, which respond to the blues. We also have medium wavelengths that respond to the green, and long wavelength L cones respond to the oranges and reds. The cones send their messages to the major bipolar cells and then to the P ganglion cells. The P cells operate slightly different than the other center surrounded organization.
I got the same thing. I added how the eye has the cones, right? And then how each cone has reflects on their own color, and when it's all like when all the colors are combined, or like the colors that need to be combined to make to like you can see the American flag. I also added that the cones are perceptor cells in the retina, which are capable of visual phototransduction. But yeah, that's pretty much it.
Number 4 is that as you stare at the flags behind the candidates, suddenly the TV cuts out, so all you see in the TV is white. Use the opponent process theory to describe what you will see for a split second. What colors would you see instead of red, white, and blue? Why would you see that? How does the book explain what is happening? When the firing rates of these color sensing cone cells so as to create the perception of these opposing colors. So what I put for that is that the opponent color theory states that there are 3 opposing channels of color in our vision. This means that if one cone is firing, there is an absence of the other. When that stops, the brain can perceive another color as a result. For example, if you're staring at the flag for a long period of time, the brain is perceiving red because the L cones are firing. When the image suddenly turns white, there is an absence of color, and your brain then interprets the color as the opposite of red, which is I think green. Yeah.
For four, what I got, I put when staring at the white screen on TV, when it is seen for a split second after the flash to appear on TV is focused, we will see the color green besides white, blue, and red. This is because the brain interprets the reduction in firing as presence of green. The opponent process organization is maintained in the LGN of the thalamus. The P cones will respond vigorously to one wavelength and reduce their firing if they receive a signal indicating a different one. These colors have been pairs so that the cell will increase its firing rate if it receives a message from one color, and it will decrease if it receives a message from another.
For number 4, I put that. Okay, yeah. For number 4, I put that opponent process theory is the concept that there are 3 opposing channels in our vision. Instead of white, red, and blue, I would see green, black, and yellow. The cones send their messages to the midget bipolar cells and then to the P ganglion cells. The P cells operate slightly different than the other centers around organization we have discussed. The P cells will respond vigorously to one wavelength and reduce their firing if they receive a signal indicating a different one. These colors have been paired so that the cell will increase its firing rate if it receives a message from one color and decrease if it receives a message from another. This creates 6 colors. Red and green are paired, blue and yellow, and black and white. Your brain interprets a reduction in firing in one cone as the opposite color.
I put that. Yeah, I pretty much got what think. Did you hear? I think I pretty much what he put. I just put that opponent process says that. Process theory says that one member of the color pair suppresses the other pair. And so if you were staring at the American flag and then the TV all of a sudden just turned white, the colors would just go to the opposite hue. So like from red to green and etc. And then I just said, shit. Well, that's the next question, my bad. Yeah, that's what I got.
Yeah. Number 5 was say, provide a brief description of how the somatosensory system transduces physical energy into active potential. Find and describe to show understanding of terms including mechanoreceptors and somatosensory cortex. Generally, how does the brain perceive information about temperature, texture, and pain from the skin?
In the somatosensory system, the sensory transduction mainly involves the conversion of the mechanical signal, such as pressure, skin comparison, stretch, vibration, to electronic impulses. Through the process of mechanotransduction, an object makes contact with the body, and the receptor cells embedded in the skin respond. And then the message travels up to the spinal cord to the somatosensory cortex of the parietal lobe. Most information we gather about texture is derived from the responses of 4 types of mechoreceptors located in the skin. We sense temperature changes to cold, hot, and cold thermoreceptors in the skin. Cold fibers respond by increasing their firing in objects that are cold to touch, while warm fibers increase firing to heat. Pain is an adaptive response due to damage. Nociceptive pain is pain caused by nociceptors. Pain serves a purpose. When a limb has been damaged, we reduce the use of limb because of the pain we experience. The gate control model suggests that the impulses that indicate painful stimuli can be blocked in the spinal cord by signals sent from the brain. The brain prioritizes the mobility over responding to the source of pain. Small diameter fibers fire to damaging and painful stimuli. When S fibers are active, a transmission cell becomes activated, the T cell. The intensity of the perception of the pain in part depends on the excitation of the T cells. When the alpha fibers are activated, they inhibit the activation of the T cells. This closes the gate, which decreases the perception of pain.
We're number 5, right?
Yeah.
Number five?
so-
Yeah.
For number 5, I put that an object makes contact with the body and receptor cells in this, and an object makes contact with the body and receptor cells in the skin respond and sends those signals up the spine to those somatosensory cortex. Most of the information we gain from touching something is processed with 4 types of mechanoreceptors built into the skin: the Merkel receptor, the Meissner corpuscle, the Ruffini cylinder, and the Passian corpuscle. The Merkel receptors fire continuously as long as the skin is making contact with an object. The Meissner corpuscle fires when the skin first encounters the stimulus and when it is removed. The Ruffini cylinder is associated with interpreting the stretching of the skin, and the Passian corpuscle feels vibration and texture. Some other skin receptors respond to temperature, constant pressure, and others to intermittent pressure. While one fiber may carry information about the temperature, another will carry information about the texture. The brain will combine these inputs to arrive at our perception of touch.
Something we didn't talk about was that the somatosensory cortex. It's located in the anterior dorsal part of the parietal lobe, and then this receives the AP signals from the skin. Well, this acts like as like a reflex. So like, let's say you touch like the stove or something that's hot, and then like those signals will be sent to the somatosensory cortex, and then your hand will just like lift up.
For 5, yeah, I think, I skipped 5. I didn't do that one. That was like one of the few I skipped.
You guys do number 6?
I don't think I can,
I did number 6.
you did? Okay, yeah, go
I
ahead.
just said that it is a sensory homunculus. It is a visual representation of what our bodies would look like if they were built in proportion to representation of the cortex. As seen in homunculus, our hands or lips are the most sensitive, and as such are largest. That's all I put.
Yeah, just like I just described how like the head and the face are bigger than like the rest of the body because they're more sensitive and they have more dedicated neurons that are in each part of the body. So like yeah, so the bigger the part of the body is, the more like sensitive it is to like stimulus.
For that one, I put the image shown on question 6 is an image that is known as a sensory homunculus. It is a visual deception of what our bodies look like if they're built in proportion to the representation on the cortex. As shown, the face and hands are large. The maps of our body on the surface of the parietal lobe are similar to the visual system. These maps of the body are spatially organized, that is, to adjacent points, as the contact of the skin maps to 2 adjacent points of the neuroactivity on the cortex. It is known as a somatotopic organization. The brain does not prioritize messages from all parts of the body equally. We see a large portion of the cortex devoted to analyzing information from the hands and face. Only a small portion of the cortex analyzes information from the torso and limbs. It also has to do with the different portions of the brain known as the somatosensory cortex. It makes contact with the body and receptor cells that embedded in the skin's response, and the message travels up to the spinal cord to the somatosensory cortex of the parietal lobe as it connects, comparing how differently the maps of the body on the surface connect with the parietal lobe.
You guys have like specific questions on any of them, or we want to move on to 7?
Not really.
Which you guys put for 7? Because I mean, I stopped at 6, and like I just looked at it, like the 7 a little bit, and I like didn't really understand.
Like the
Yeah.
question, like what happens is like he gives a bit like the story, like he gives like an example, and then like in the second part he asks what he wants. So it says like, what do psychological and brain scientists call the ability to move your body in space? What I put for that is that in order to move our body in space, we need to rely on the kinetic sense. This sense works with others like touch and vision to know where our body is relative to space. The receptors for this sense are located in our joints, ligaments, and bones. And then it says it asks for like, what do psychological and brain scientists call the ability to sense balance? And for that one is the vestibular sense is responsible for balance. And then the receptors are located in the ears, which have semicircular canals that are lined with hair to sense head rotation and acceleration. And then the last part of the question was like, what does it let us do? So like, it just lets us like walk, be able to do gymnastics, all that.
Is there anything that you guys found like hard?
It's long, but he talks a lot.
Yeah. I
Makes it
think,
really long.
let's see. For that one, yeah, I pretty much got the same thing. I just said that the ability to move your body in space is known as the vestibular sense, and the sensory cells are in the cochlea, and two structures respond to posture, acceleration, and movement. And the semicircular sense changes in acceleration and rotation of the head. And then these canals are filled with hair cells that respond to the amount of gravity. And then after that, I put the vestibular sacs are responsive to certain cues that have a sense of balance and posture. And that's what makes our balance and like our movement relative to like what we're doing pretty much.
Yeah.
Did you guys read chapter 5 and 6?
I mean, chapter 6 was only like the last 3, 4 questions that you're here.
Yeah, it tells you like it's chapter 6, so I
Like,
was
the
just going
beginning or,
through.
like the middle or the end of the chapter?
Like the beginning, huh?
Because I didn't read 6 at all.
Yeah. It's kind of like all over the place sometimes.
Like 5, I didn't finish reading that one. And when I had to do the questions, like I literally like just put my best guess.
Yeah.
I just do control find. I don't read shit, honestly.
Yeah, I'm real. I just be looking through with like what's it called, Control F, and just put like a word down.
Yeah. And then read
Yeah,
that section. I just read that and then I'll just like summarize.
that's it. Yeah, I feel it.
Yeah.
That's
Or
fine.
I just look for like the definition on the book, and then I know that it starts from there to like the bottom.
Yeah, because if you read the whole book, you're not gonna
Yeah, you're not
finish.
gonna remember anything. Yeah,
You're
exactly.
not gonna finish, bro. You can read it after, but like not right now.
Yeah.
Through the professors just like literally like answer one by one like what we have, because he
Yeah.
doesn't even explain it. He just
Bro,
goes
he
over it and that's it.
just talks, dude. Like doesn't even like say, "Oh, this is number 8. This is for number 9." He just talks and then moves on.
And like how
I
would
don't
you know
really
the
be
right
going to
answer?
those.
Still recording, by the way.
Yeah, we're done. We're pretty done with it, honestly.
Guys,
27?
Alright.
recording.
What's
How much time I have left?
Like 3 minutes. Like,
Oh, like 3 minutes. Oh. Is there any other
Yeah.
ones?
mm,
Which questions give you guys the most trouble?
number 10 was hard. Not gonna lie.
What was number 10?
Yeah,
The one with the split brain surgery
yeah.
one, the corpus
Yeah.
callum. Yeah, I didn't really like that one. I had to like watch video on that.
I hated number 1. I didn't really understand the last chapter. Well, I did, but like the stuff about the P cells, the ganglions, I did not understand at all.
Oh, yeah.
Wait,
No,
so you have 3 minutes left or 8 minutes?
we have like 2 minutes.
Okay.
For 10, what I put? I just put that they call these type of people who got the surgery split brain, and they do these
Yeah.
surgeries to reduce the frequency of seizures and epilepsy. And some of the symptoms would be that like one side of like their body or like on their brain has like a mind of its own. And so like there's some cases of where like the left hand will put the book down, even though like the left hand will put the book down, even though the person actually had interested in it in his right brain. And then there was another case where like a man was like, I think it was like about to hit his, I don't know if he hit his wife or was about to, with one hand, but then tried protecting her with the other hand.
No,
And
I think he was protecting her with one hand, and then like with the other hand, he was just trying to hit her.
yeah,
It was crazy.
I looked that up. I looked it up. I was just like, that's hella interesting. Like that's weird. Like how that could be like,
But, like the question was like, oh, like what would the person be able to write or like draw? If they're seeing something with
yeah,
the right or left side.
Yeah,
Just
that
do-
part I didn't really, yeah, I just kinda put it down.
Does it ask, what would a post-surgical patient draw with their left hand? What would they say when asked to see what they saw on the left side? And then what would a post-surgical patient draw with the right hand? What would they say? I mean, I don't know if I got it right. I just put that with their left hand, they would be able to they'll be able to draw a cat, but they wouldn't be able to tell you what it is. And with the right hand, they'll be able to draw it, and then they will also tell you that it's a dog, because the dog's on this side, and it's on the right hand. I don't know.
Do you guys think that I went off a question like that didn't sound right at all?
Which one?
No, like I'm saying, like when I was speaking, like did one pop out to you? You're like, what the fuck, like sorry, like that's not right.
Nah.
Think so.
Because sometimes I feel like I don't even like it's not even right.
He only grades 3 of them, huh? Just like 3 random questions.
Wait,
Huh?
did I ask? Like on the whole thing?
Yeah, the whole thing he just grades 3.
Oh, I swear to God.
So
I didn't
like
know that.
you don't even know which one it is.
Yeah, yeah.
Like, it could be one of the easiest ones and just grade that one.
Lately, when they've been grading mine, they literally grade the wrong one, the one that I don't.
Yeah.
And it sucks because like it would be good if we could go back and like do it over,
Mhm.
but we can't even do that. Like that's our final grade for that.
Right. Are we good?
Yeah, we're good. I'm gonna start recording. Hold on.